here at ITF 2024. I'm at the booth entitled Ultrasound and Photoacoustic Medical Imaging. It is very interesting to find out what imec is doing in this field. I'm with Hilde. Hilde, thank you very much for having me at this ITF 2024. I'm having so much fun. What are you doing in the field of photoacoustics?
Yeah, so we are developing photoacoustic medical imaging devices. That's what we are doing, but it should not be medical imaging only. It's like a platform technology that we developed can be used for sensing and other applications too. So what we have on display today is really like a system where you can have the combination of optics with acoustics. That's what it is. So standard ultrasound methodologies, they have like an image which is grayscale, but if you add light to it, you can have molecular information. So that's the beauty of the technology. So you shine light in, and so there is an absorption event taking place on, for instance, if you take
Is it coherent light? Is it laser light?
No, it's indeed, it's a LED. So here you see the LED, for instance. So these are the light sources we use. It's like a standard LEDs, and you can change color. So we have here 850 in the system. So 850 will go through the material, but it will be heavily absorbed by the wires that we put in that phantom. So that will create an acoustic wave, and that will be captured by a very sensitive microphone. And that's the microphone we have here on display. So this is basically an optomechanical ultrasound sensor. It's basically a ring resonator with a membrane on top.
A membrane on top?
Yeah, so it's a freestanding membrane on a ring resonator, and it vibrates, and it comes closer to the ring, and it should give rise to a change in the transmission of light.
You are changing the resonance frequency?
And the resonance frequency, yes, correct. If you look at the screen here, so we did a measurement at two wavelengths. One is 528, and if you use that wavelength, we only see the skin surface, so the tissue surface. When you modify the wavelength, you see the absorption only from the hemoglobin in the vessels. So that's what you see here at depth. So that's what it is very nice about photoacoustics. So you can give contrast to the molecules or the structures you want to give contrast to.
For this, you're using a standard silicon photonics platform?
Photonics, yes. It's all made in silicon. It's an optical waveguide technology, but it's MEMS because it's a freestanding membrane onto a photonic layer. That's what it is. It's a very sensitive device. So we have a Nature publication on this.
Making a sensitive ring resonator is fantastic. Interrogating a sensitive ring resonator is where the art is.
Yeah, I know. So that's also what we're working on. So combining integrated lasers with this, and also do the readout. So the photo detection at the other side, yes, that's a research field, but we don't have it on display today, but we are working on it. So yes, imec has the technology in-house to make integrated lasers. This works at 1515. So this is like a standard wavelengths. So it's not the most difficult one to have integrated sources for.
These arrays of pressure sensor can combine many, even thousands of reading points. What is the key application that you would see on having such a way of integrating pressure sensors into a same chip? What kind of problem do you want to solve with this?
So it's very nice to have spatial information and also know the molecular information spatially over an area. And it can be useful for multiple things in medical imaging, but also if you think of metrology, inspecting wafers or other things, it's very nice to know the spatial location combining the information that you're looking for.
Fantastic.
That's important.
When we had this interview in 2028, what is your preferred future? What kind of things would you like to tell me differently?
Wow, that's a difficult question, but I like to see like a fully integrated thing, combining light sources, arrays of ultrasound detectors, and also the detection part all on chip in a monolithic fashion. That would be great to achieve that.
And by when do you think we can see it in a clinic?
In a clinic? Okay, that takes some time because it's a new technology that you want to bring in. It's a new imaging modality, so that takes time. So then we talk about 10 years, I believe. But okay, we are talking with physicians already, so it's getting them to know the technology. But if you see it as a combination of ultrasound with some new add-ons, I think it can work.
So if your preferred future is to see this develop in a common integrated platform, how can we see this being interacting with medical doctors? Is there a roadmap? Is there a plan for medical doctors to talk to you and to tell you maybe the specifications of their dreams?
Yeah, I think IMEC is always trying to connect the dots. So we have our university collaborations, our hospital people, our clinicians. We talk with them very often to get really the specifications that they need, like, and also what are the targets they're looking for? What is it that they want to measure? So that's what we are doing, yes. And then understanding, like, also if you develop such a thing, what wavelengths do you need to find these markers, and then have our engineers thinking how to build such future devices, but also to give them like a look. How can things look in the future? How can it be miniaturized? What can it be? Can it be a patch? Can it be like a small clip or whatever? So that's what we are trying to make them visible. Like how should that look like? And I think that helps to get them enthusiastic about what we are developing, and help us commercialize this in the end, right?
Silicon photonics, ring resonators, measuring ultrasound, and showcase for medical applications in photoacoustics. Impressive. Let's continue the interviews at ITF 2024.